limit comparison test. The statement is if sigma un and a sigma vn, sigma un and sigma vn are two positive term series, sigma un and sigma vn are two positive term series such that limit of the ratio un over vn as n tends to infinity is limit L. Limit L. Then the first condition is, all of you, the first condition is if L is finite and non-zero. I missed in the last class this statement. Okay, is it audible? And
yes, sir.
Okay, L is finite and non-zero. What is the value of L? Maybe 2 or -2 or fraction, any real number which is finite but not zero. L is finite and non-zero, then both sigma un and sigma vn, converge together or diverge together. This is the first condition. Remember, what is the limit of, what is the ratio un by vn? For that ratio, take limit n tends to infinity, you will get one limit L. If that L value is non-zero and a finite value, then both the series converge together or diverge together. And the second point, if L equal to 0, limit value is 0, and another condition is with L equal to 0, another condition is sigma vn is convergent. L equal to 0 and sigma vn is convergent, then sigma un also convergent. Next, third one, if L value is tending to infinity, the limit may be infinity also, right? Then L is tending to infinity, and another addition condition is sigma vn is divergent. Then sigma un also divergent. These are the conditions for the limit comparison test. Totally 3 conditions. What is this? Limit un by vn as n tends to infinity is L. If the limit value is non-zero finite value, then both the series converge together or diverge together. Meaning is what? If sigma un is convergent, then vn also converge. Sigma un diverge, then vn also diverge. And second condition is if limit value is 0 and the sigma vn is convergent, then sigma un also convergent. And the third one, if limit is infinity and sigma vn is divergent, then sigma un also divergent. This is limit comparison test. Okay. And yesterday I have given one P series test. You remember, this is very important in solving problems. P series test. Just I'm briefing. What is a series? Sigma 1 by n power p. Sigma 1 by n power p, n is always 1 to infinity, is convergent if p greater than 1, is divergent if p less than or equal to 1. And definitely this p must be greater than 0. Always remember, p must be greater than 0. You just remember this p value, if it is greater than 1, convergent, and less than or equal to 1, divergent. This is limit comparison test. And the comparison test 1, test 2, I will again explain those in solving the problems. Now let me take one problem. Comparison test. Test the convergence of the series. Series is 1 by 4 into 7 into 10. 1 by 4 into 7 into 10 plus 4 by 7 into 10 into 13 plus 9 over 10 into 13 into 16 and so on up to infinity. This is one infinite series. Okay, always remember only one series is given here. What is the sigma un here? Sigma un, the series sigma un is 1 by 4 into 7 into 10 plus 4 by 7 into 10 into 13 and so on, right? Now to decide to write this one, okay, just give me a minute. I have to add some more slides. Now to decide the convergence of the series, I have to write what is the series here. Sigma un equal to 1 by 4 into 7 into 10 plus 4 by 7 into 10 into 13, and next one is 9 by 10 into 13 into 16 and so on. Okay, and what is the first, let me find the nth term. Always to decide convergence or divergence, we need nth term. Remember, we need nth term. This is first idea. So what is the nth term? This is un. I have to write in terms of n. The nth term is un is equal to, see, the first term. What is the first term? This is 1. In the first term, the numerator values, every term is a fraction. In that fraction, the numerator values, let me see, 1, 4, 9, right, and so on. So what is this one? See, first term is 1 in numerator. I'm talking about numerator. And in second term, it is 4. In third term, it is 9. Definitely in fourth term, it is 16, like that. Therefore, what is this term? This is n square. This is about numerator, right? Coming to denominator, what is that? In the denominator, what is the first terms in the product of 3 terms? Denominator is the product of 3 terms. In that product, see the first term, 4, 7, 10. What is those terms in denominator? 4, 7, 10. Next one is definitely 13 and so on. So what is the nth term formula? This is in arithmetic progression, right? A plus n minus 1 into d. So 4 plus n minus 1 into, what is the common difference? 3. So 3n plus 1 will be the first product. First term in the product. 3n plus 1. Obviously, the second one is what? 7, 10, 13. You can write directly. For 4, how much is added? 3 is added. So you can write, for the first term, you add plus 3. So this becomes 3n plus 4. Similarly, again plus 3 for the second term. Therefore, second product term, 3n plus 4 plus 3 plus 7. This is the nth term of the given series. Any doubts? Nth term of the given series. Any doubts? In denominator part is clear, right? Now, see. Now tell me, is it geometric series? Given series is geometric? No, right? It is not geometric series, and it is not the series of the form 1 by n power p. It is also not of the form 1 by n power p, right? Now, the thing is here, whenever the series contains, remember this statement clearly and keep in mind, when a series does not involve factorials, and x power n's, x to the power of n terms in the series, then apply limit comparison test or comparison test 1 or test 2 or limit comparison test. What is the thing? When the series does not contain x to the power of n terms, in this nth term there is no x power n and there is no factorial, then go for comparison test 1 or test 2 or LCT. LCT stands for limit comparison test. Therefore, now coming to limit comparison test, what is the limit comparison test? See, what is the limit comparison test? I have to find the limit of what? Ratio. What is that ratio? Un by Vn. I know Un. I know what is the nth term Un, but I don't know what is Vn. I don't know what is Vn. So there is a, now we have to find the series Vn. Both must be positive term series. The first point is that is important. Un, and remember this statement also. Okay. What is this? The important statement is express Un as function of 1 by n's. Function of 1 by n's by taking n common in numerator and denominator. That is, this is the procedure to find Vn. Already this is n square. This is n square. And you take n common in every term. So outside it becomes n into n into n cube. So this becomes 3 plus 1 by n. And this is 3 plus 4 by n. And this is 3 plus 7 by n. 3 plus 7 by n. Then what you will get? 1 by n square into 1 by 3 plus 1 by n, 3 plus 4 by n, and 3 plus 7 by n.
So 1 by
7
n.
by what? Where?
1 by n square.
1 by, yeah.
1 by n.
After getting cancel n square n, this is 1 by n. And this is un in terms of 1 by n's, correct? Un in terms of 1 by n's. Then here hint is choose the series sigma Vn and Vn where Vn is of the form this Vn must be what form? 1 by n power p structure. Vn must be chosen in the form 1 by n power p. Now what is that in this total term? Where is 1 by n power p structure? Here it is there. Yes. Now so choose Vn as 1 by n. Choose Vn as 1 by n. This is the idea to select the series Vn to apply limit comparison test. Cn, then what is sigma Vn is nothing but now sigma 1 by n power 1. P value is what now? 1. According to our test, according to our P series test. Do you remember P series test? What is the P series test? Sigma 1 by n power p converges if
P is greater
than 1 and diverges if p less than or equal to 1. And what is the p value here?
1.
1 is
The
divergent. Okay, now let me apply limit comparison test. For limit comparison test, what I have to find first? Ratio un by vn. Then just wait. Un by vn. Who is that? Someone joined. మధ్యలో జాయిన్ కాకండి అయ్యా క్లాస్ మధ్యలో. Now un by vn is what? If I take this un by vn, this 1 by n gets cancelled, right? Un by vn, then what are the remaining terms? 1 by 3 plus 1 by n, 3 plus 4 by n, and 3 plus 7 by n. Okay, after taking un by vn ratio, then take limit value. Limit n tends to infinity, un over vn is equal to limit n tends to infinity 1 upon 3 plus 1 by n, 3 plus 4 by n, and 3 plus 7 by n. So something by infinity, this is something by infinity,
0.
something by infinity 0, 4 by infinity 0, 7 by infinity 0. So what are the remaining terms? So 1 by this is 3 plus 0, 3 plus 0, 3 plus 0. So what is this value? 1 by 27. This is the value of L. Shravya, hello, speak up. Shravya, who is the last one who joined? Now, this is 1 by 27, that is value of L. This is, which is finite and non-zero, which is finite and non-zero, equal to finite and non-zero. Therefore, the statement how you conclude by using LCT. LCT means limit comparison test. By using limit comparison test, what is this? What is limit comparison test? Since sigma Vn is what? Sigma Vn is what? Divergent.
Convergent.
Sigma Vn. What is this? Divergent.
So 1 by
Yeah, 1 by n. When p less than or equal to 1, what is the 1 by n power p?
okay.
Divergent.
Yes, sir. Divergent.
Yes? Yeah. Sigma Vn is divergent. Therefore, sigma Un also divergent. What is this? Why this is? Because of first condition of limit comparison test. What is the statement? Once again, when L value is finite and non-zero, both series converge together or diverge together. I know sigma Vn is divergent and limit value is finite and non-zero. Therefore, sigma Un also divergent. Okay, this is one simple problem. Next one, second problem. Test the convergence of the, I am not writing the problem, the statement, just directly I am giving the series. Test the convergent of the series. Series is 1 plus 1 by 2 square plus 2 square by 3 cube plus 3 cube by 4 power 4 and so on. 4 power 4 and so on. Right? This is one infinite series. Is it geometric series? No. Is it the series of the form 1 by n power p? No. So, is this series contains any x power n's? No. Factorials? No. So, go for limit comparison test. So, what is the nth term? Anybody? Nth term. The nth term is
n square by n plus 1 whole cube.
n minus 1 whole square by n square. N minus 1 whole power n by
1 power n minus 1 by n power n.
what?
n minus
N?
1 whole power n minus 1 whole power n
Whole power
N
n
1 power n minus 1 by n power n.
by n power n.
1 by 1. Please tell anyone, only one, anyone?
by
Sir,
n
n
power
power n by
Whole power n by
n plus 1
okay,
into
n power n by
n plus 1 into n plus 1 into n plus 1
n plus 1
into n, sir, whole n
into n
plus 1.
plus 1.
Sir, can I say?
Wrong.
Down, sir, in the denominator, sir, plus 1.
n minus 1 whole power n minus 1.
n minus 1 whole
Evara
power
in the
n minus 1 divided by n power n.
Yes, sir.
n power n. If I put n equal to 1, see, all of
Sir,
you, listen. Vinandi.
n power n.
If I put n equal, Rama, Vinandi. If I put n equal to 1, you have to get first term. If I put n equal to 2, you have to get second term. N equal to 3, you have to get third term. That is the idea. I put n equal to 1, you have to get first term. N equal to 2, second term. N equal to 3, you have to get third term, like that. So what is the nth term?
N power n by n plus 1 whole power n plus 1.
N power n by
N plus 1 whole power n plus 1.
put n equal to 1. You have to get first term.
Oh.
Sir, it is n minus 1 to the power n minus 1 by n power n.
N minus 1 to the power n minus 1 by
N power n.
n power.
N.
Put n equal to 1.
It's coming, sir.
Hey, n equal to 1.
0
If I
power.
put n equal to 1, what is the value?
Sir, 0
It's
power
coming.
0.
Arey wow. N equal to 1, what you will get? 0 by 1 power 1.
Yes, sir, it's not coming.
Sir, will neglect first term, sir.
Sir,
We'll
we can
remove
write
first term, so we'll keep it and take the series from second term.
Yes, exactly. What is your name?
Rohit sir.
Rohit. See, all of you. అందుకే నిన్న క్లాస్ జాగ్రత్తగా చదువుకోమన్నాను. Properties of series. What I told properties of series, if I remove some finite number of terms from the series, infinite series, it does not affect the convergence of the series, correct? Property is there, na? Series.
Yes,
I
sir,
can
yes, sir.
remove some finite number of terms. I can add some finite number of terms to the series, right? There is a property. So using that property, I can write. Now neglect the first term. Forget about the first term. Then now you can tell me what is the nth term. N, first one, n equal to 1, n equal to 2 means 2 square means if I put n equal to, so n power n, 3 cube, 4 cube. Forget about the first one. This is 1 power 1. 1 power 1 by 2 square means n plus 1 whole power n plus 1. Is it correct? This is by, you must write in examination also, by neglecting first term. By neglecting first term. Okay. Any doubts? Yes. Right. Next one is, after getting nth term, what I have to get Vn. For Vn, I have to write what? Un is equal to, take n terms common. So numerator as usual. In the denominator, if I take n common, outside it becomes n power n plus 1. And this is 1 plus 1 by n whole power n plus 1. Okay. Now what is this? Un becomes Un equal to n power n gets cancelled. 1 by n into 1 plus 1 by n whole power n plus 1. So what is Vn? So choose Vn equal to 1 by n, so that sigma Vn equal to sigma 1 by n. What is the series? P value is 1. So divergent. Divergent. Now you find the ratio. Now Un over Vn, 1 by n gets cancelled. The remaining terms are, term is only one term, 1 by 1 plus 1 by n whole power n plus 1. Apply the limit value Un by Vn as n tends to infinity. So limit n tends to infinity, 1 by 1 plus 1 by n whole power n plus 1. What is the value? What is the limit value?
1.
And
1. Limit value 1.
yes, sir.
Em peru? What is your name?
1 power infinity form.
1 by infinity.
No.
1
Ah,
power
sir.
infinity.
Whenever n tends to infinity, right? N plus 1 can be written in this format, right?
Yes, sir.
What is this value? First limit value. What is this limit? N tends to infinity, 1 plus 1 by n whole power n, and the limit of this one is 1 plus 1 by 0. What is this?
1 by e.
1 by e, exactly. Not equal to 0 and finite. In examination, if you put 1, we will cut the marks. This is the original answer, L value, 1 by e. Is not equal to 0 and finite. Since sigma Vn is what series? Already we have this as a divergent series. Sigma Vn is divergent by using limit comparison test. Sigma Un also diverges. Sigma Un also diverges. Okay. And the next problem. Let me take sigma n is 1 to infinity under root 3 power n minus 1 by 2 power n plus 1. 3 power n minus 1 by 2 power n plus 1. Come on. Solution. All of you, solve yourself. I'm telling this is nothing but sigma un. Sigma un is nothing but sigma under root 3 power n minus 1 by 2 power n plus 1. Therefore, what is the nth term? Nth term is given directly here. 3 to the power of n minus 1 by 2 power n plus 1. 2 power n plus 1. Now, take 3 power n common. 3 power n common outside. So, this becomes 3 power n, root 3 power n, 1 minus 1 by 3 power n, and 2 power n common. This is under root 1 plus 1 by 2 power n. 1 plus 1 by
Divergence.
2 power n. So what is this becomes? I can write this is, shall I write 3 by 2 whole power n by 2, this part?
Yes.
Is it correct? Any mistake or any corrections?
Correct,
It's
sir.
correct.
Right? So this is un. So choose vn as what?
3 by 2 whole power n by 2.
3 by 2 whole power n by 2. Now see, all of you, listen here. 3 by 2 whole power n by 2. This implies sigma vn, sigma 3 by 2 whole power n by 2. Now this series is not of the form, what is the series here? Sigma vn is not of the form sigma 1 by n power p, correct? Previous two problem we had this. Now for this problem it is not like that. And what is n is always from 1 to infinity. Let me expand this. Put n equal to 1, 3 by 2 whole power 1 by 2. N equal to 2, 3 by 2 whole power 2 by 2. N equal to 3, this is 3 by 2, and so on. What is the series? Is in GP, isn't it?
Yes.
Isn't it? With the common ratio, with the common ratio, what is the common ratio? R value? I think 3 by 2. 3 by 2.
Root
correct?
Root, sir, root.
Root 3 by 2. Root 3 by 2 means under root of 1.5. Greater than 1 or less than 1?
Greater than 1.
Square root of 1.5 greater than?
Greater than 1.
Greater than 1. Therefore, when greater than 1, geometric series is what? Sigma Vn is
Divergent.
divergent. Sigma Vn is divergent by using geometric series test. By using geometric series test. Now, let me write the ratio. Our limit, now come back to limit comparison test again. I'm taking directly limit for the ratio, limit n tends to infinity, un by vn. This is un, this is vn. So these 3 by 2 power n by 2 terms gets cancelled, and the remaining is under root of 1 minus 1 by 3 power n by 1 plus 1 by 2 power n. So obviously this is 1 minus 0 by 1 plus 0. The value is 1, not equal to 0 and finite. Right? Therefore, not equal to, since sigma vn is divergent, using, you have to write in examination this statement compulsory, using limit comparison test, sigma un also divergent. Sigma un also divergent. Now let me tell you one problem on convergent. On convergent. That's simple. Again divergent, that is also. I need convergent now. Yeah, take this problem. Test the convergence of the series. What is the series? Square root of 2 minus 1 by 3 cube minus 1 plus cube square root of 3 minus 1 by 4 cube minus 1 square root of 4 minus 1 by 5 cube minus 1 and so on. Come on. What is the nth term?
Root over
What
n
is the
plus
nth term?
root root of n plus 1 minus 1 by n plus 2 whole cube minus 1.
Yeah, see in the first term, this is started with the square root of 2. So plus 1. So n plus 1 minus 1 everywhere, minus 1 is there. By what is this one? N equal to 1 means here 3 cube is there. So I think n equal to 1 ante 3, n plus 2 whole power n plus 2 minus 1. Is it correct?
Whole cube.
N plus 2 whole cube, sir.
That's enough. It is enough. Yeah, n plus 2 whole cube minus 1. Right. Now let us express as a function of 1 by n. Take in the first one n common. So this is 1 by n. This total under root minus 1 by n common outside n cube. 1 plus 2 by n whole cube minus 1. I have taken n common in the first term only in un. Now overall common. Root n is common. Under root of 1 plus 1 by n minus 1 by root n whole by n cube is common in entire denominator. 1 plus 2 by n whole cube minus 1 by n cube. Minus 1 by n cube. So what is this is? 1 by n power 3 minus half. 3 minus 1 by 2. N power 5 by 2. Isn't it? This is 1 plus 1 by n minus 1 by root n whole by 1 plus 2 by n whole cube minus 1 by n cube. This is un. So choose Vn as what? Choose Vn equal to 1 by n power 5 by 2. That is sigma Vn equal to sigma 1 by n power 5 by 2 is what? Convergent. Is what? Convergent.
Greater
Sigma
than
1 by n power p is converge if p greater than 1. Okay, this is the idea. Now take the ratio. For the ratio, limit directly. Limit n tends to infinity un by vn. Un by vn means these two terms gets cancelled. 1 by n power 5 by 2, 1 by n power 5 by 2. And for the remaining term, the limit is 1 plus 1 by n under root minus 1 by root n whole by 1 plus 2 by n whole cube minus 1 by n cube. So this is 1 plus 0 and this is 0. This is 1 plus 0 whole cube minus 0. So this is 1 not equal to 0 and finite. Therefore, you write like this. Since sigma Vn is convergent, sigma Vn is convergent, comma, by using limit comparison test, sigma un also convergent, because both converge together or diverge together according to limit comparison test condition 1. Limit comparison test condition 1. Now another problem. Solve problems you can do. I will solve exercise problems. Yeah. 2 by 1 power p. 2 by 1 power p plus 3 by 2 power p, 4 by 3 power p, 5 by 4 power p, and so on. Solution. What is the nth term? Un equal to, the starting term start with 2. First term 2, second term 3, third term 4, like that. So n plus 1 by first term 1 power p, 2 power p, and so on. Therefore, this is what? N power p. Simple problem. Anyway, this is. And I can write this un by taking n common in numerator and denominator. So what I am getting? 1 by n power p minus 1 into 1 by 1 plus n. Sorry. This is 1 by n power p.
Today we will be integrating the
Hello?
illustration on the platform, and I have one more case.
Hello, sir.
The one that you talked about is the first one, right? Yes. The one I'm doing today, another one, yeah, regarding that there was some SLO, so single logout was not configured.
Did sir leave the meeting?
Sir left the meeting.
He had some connectivity issue, I guess. He'll probably join back.
The same thing.
What answer are we getting for the last question?
That's why it's clear in yeah, so basically this is arising because
Hello.
Yes, sir.
in Orlando and it will be good because
Power పోయిందమ్మా.
so it's better if we backboard.
ఇక్కడ వరకు చెప్పాను. ఇక్కడ వరకు వచ్చింది.
Because if they do the work around
Un equals to 1 by n power p minus 1.
Ahmad Jalal, please mute yourself. ఎక్కడి వరకు వచ్చారమ్మా? హలో, ఏ ప్రాబ్లం వరకు వచ్చారు?
First, sir. First one on listed.
హలో,
First one, sir.
ఏది సిగ్మా 1 by n sin
2 power
Yes.
1 by
2 by 1 power p plus 3 by 2 power p plus 4 by 3 power.
is that finished?
This one.
No, sir,
no,
just
sir.
started.
Yes, start.
Finished or not?
No,
We
sir.
started this one.
Acha. Right. Listen once again. For this series, the nth term is what? First term numerator 2, second term numerator 3, third term numerator 4. So nth term is numerator n plus 1. And denominator, first term 1 power p, second term 2 power p, third term 3 power p. So nth term is n power p. Let me express un by taking common n on numerator and denominator. N is common in numerator. So n equal to n into 1 plus 1 by n power p. So this can be written as 1 by n power p minus 1 into 1 plus 1 by n. So what is my Vn? 1 by n power p minus 1 is my Vn. And to decide convergence divergence, we know the power is 1 by n power p. If p is greater than 1, converge, less than or equal to 1, diverge. Now here, what is the power? P minus 1 instead of p. So when this p power is greater than 1, so p minus 1 is greater than 1 means p greater than 2, series is converge. And p minus 1 less than or equal to 1, series is diverge. Series is diverge. So p less than or equal to 2. Taking ratio un by vn, I am getting 1 not equal to 0 and finite. So by using limit comparison test, sigma un is converges for p greater than 2 according to vn. For vn is for p greater than 2 converge. So un also converge for p greater than 2 and diverge for p less than or equal to 2. So un also diverge for p less than or equal to 2. This is the model, one model problem. And another one is sigma 1 by n sine 1 by n. Sigma 1 by n sine 1 by n. There are two ways to solve this problem. Two ways to solve this problem by using one is by using formulae. The first formula is in intermediate we know that limit theta tends to 0 sine theta by theta is 1. Or one can write sine 1 by theta by 1 by theta. I'm taking the reverse 1 by theta by 1 by theta. As theta tends to 0, 1 by theta tends to what? Infinity. So limit 1 by theta tends to infinity, sine 1 by theta by 1 by theta is also 1. Let me use this formula now. Second, this one. This is un equal to 1 by n sine 1 by n. So I will write this one as this equal to, this is 1 by n only now, sine 1 by n by n. Observe, sine 1 by n by n. This 1 by n comes as n. But I have to get what here? If it is 1 by n, this denominator must be also 1 by n. So for that, I will write 1 by n here and I will multiply. What is this? To get n here, I have to get n square, correct?
Yes, sir.
Any doubts? So I can write now this as 1 by n square sine 1 by n by 1 by n. This is my un now. This is my un. Now choose vn as 1 by n square. That implies sigma vn equal to sigma 1 by n square is what? Convergent series. Is convergent series. This 2 is greater than 1. 2 is greater than 1 converge. Therefore, now whatever the limit value, limit un by vn as n tends to what? Infinity is equal to 1 by n square gets cancelled. Limit 1 n tends to infinity sine 1 by n by 1 by n. What is this value? I told you the formula. What is this limit? 1 by theta by 1 by theta, 1 by theta by 1 by theta, as limit 1 by theta tends to what? 0 is value 1. Is value 1. Previously also this is 1 by theta tends to 0. 1 by theta tends to 0. This is 1. That is nothing but limit sine 1 by theta by 1 by theta. 1 by theta tends to 0 means theta tends to what? Infinity. This value also 1. Is that clear? Right? Yes. Limit theta tends to infinity. Sine 1 by theta by 1 by theta 1. Exactly. This is my 1 by theta, and theta tends to infinity. So what is this value? 1. Not equal to 0 and finite. Not equal to 0 and finite. Therefore, by using limit comparison test, since sigma vn is what this series sigma vn already convergent. Since sigma vn convergent, sigma un also convergent. Sigma un also convergent. This is one way of proof of this series, sine 1 by n into sine 1 by n, or otherwise, what is my series? 1 by n into sine 1 by n, right? Yesterday in the first class, someone told what is the sin x expansion?
X minus
Sin x
x cubed by 3
expansion.
factorial. X minus x cubed by 3 factorial plus x to the power 5 by 5 factorial.
And so on, right? Right? Now let me apply this series formula for sine 1 by n. Sine 1 by n. In place of x, what is the value here? In place of x, what is the value?
1 by n.
1 by n.
1 by n.
So sine x value is 1 by n. So 1 by n minus 1 by 3 factorial x cube, 1 by n cube plus 1 by 5 factorial, 1 by n power 5, and so on. Isn't it? Now take 1 by n common in the series. So outside it, 1 by n into 1 by n, 1 by n square, by 1 by 3 factorial, 1 by n square, 1 by 5 factorial, 1 by n power 4, and so on. And so on. That is equal to 1. Okay, this is my un now. So choose Vn as what? 1 by n square. That implies sigma Vn equal to sigma 1 by n square is convergent series. Okay. Now apply limit un by Vn as n tends to infinity. 1 by n square gets cancelled. So limit n tends to infinity for what? 1 by 3 factorial, 1 by n square, 1 by 5 factorial, 1 by n power 4, and so on. So obviously what is this? Every term will be 0, something by infinity 0, except 1, not equal to 0 and final. Therefore, by LCT, since sigma Vn is convergent, sigma un also convergent. All of you see, every step I am writing because it is not a JEE mains or MSET. You have to write in examination also, and prepare your notes also in this manner. You have to write every step. Don't skip. Answer వచ్చింది కదా అని skip చేయొద్దు steps ni. Okay, marks కూడా cut అవుతాయి. So this is one model problem, 1 by n into sine 1 by n. Okay, and you solve this one assignment, one problem. 1 by root n into sine 1 by n. 1 by root n into sine 1 by n. And second problem, 3 by 5 plus 4 by 5 power 2, 3 by 5 cube, 4 by 5 power 4, and so on. Next problem. 1 by 1 square, 1 plus 2 by 1 square plus 2 square, 1 plus 2 plus 3 by 1 square plus 2 square plus 3 square, and so on. And so on. Fourth problem. 3 by 1, 4 by 8, 5 by 27, 6 by 64, and so on. Fifth problem. That's simple. Summation n square plus 1 minus n. Sixth problem. Sigma cube root of n cube plus 1 minus n. Seventh problem. Summation n power 4 plus 1 minus n power 4 minus 1. Next one, eighth problem. Summation 1 by root n into tan 1 by n. Tan 1 by n. Next one, ninth problem. Sigma 1 by under root n into log n. N is from not 1 here, 2 to infinity. 2 to infinity. And the last problem, that's easy anyway. Okay, summation n plus 1 under root minus 1 whole by n plus 2 whole cube minus 1 whole cube minus 1. That's it. Okay, these are the 10 assignment problems based on limit comparison test. And one more finally, summation n is 2 to infinity 1 by log n, 1 by log n. Okay, try these problems. Any doubts? Any doubts? Any doubts?